My name is Valerie Berry. I'm in electrical engineering, and I'm here with Austin Welch, who is a grad student.
Hi. What we have here is the University of Idaho Clean Snowmobile Project. What you see behind me is our competition snowmobile from a couple years ago. The whole point of our competition is to develop a snowmobile that is clean, quiet, and fuel efficient, but that is also fun to ride. That's currently our main design goals. We have several ways of accomplishing this. We do a lot of engine design, we do a lot of muffler design, acoustic type design. We also do a lot of sound deadening type design where we look at vibrations throughout the snowmobile and try to dampen some of that noise. There's currently about 15 people that are on our team, ranging everywhere from freshmen to seniors to graduate students.
So I understand you guys entered 3 projects in the Engineering Design Expo. Why don't you tell me a little bit about each project?
Okay, the first project we entered is just for our team overall. It's just to let people know what we do as a team at the University of Idaho and to try to get people more involved. The second two, one is an engine design project where we're working on making our engine more clean, quiet, and fuel efficient. And the third one is a muffler design where we've tried to really cut down on noise, because for us that's one of our biggest hurdles, is to eliminate noise of the snowmobile.
So I understand you're a grad student. What was your role on the project?
As a grad student, I am a graduate mentor for a lot of the senior design teams. I just kind of help facilitate projects and get ideas flowing and help them whenever they need help, either manufacturing or coming up with ideas or anything like that.
How would you say that these projects have real-world applications?
Well, like our engine design that's over in the corner here, it's currently being patented as we speak to be put into production as a small engines if it works for small engine development. And it can be seen in the next few years, hopefully, in a snowmobile that you might purchase at a manufacturer.
So as a mentor, what was your biggest challenge throughout the year?
My biggest challenge is trying to, I think, keep some of these guys motivated and keep them on track, and to make sure that they are completing the goals necessary to complete their project.
What was the biggest breakthrough that any of these teams had this year?
The biggest breakthrough? Probably the biggest breakthrough that we've had was getting everything to come together on our synchronous charge trapping engine and just see it work and see the applications that its potential in the industry.
And how would you say that these projects and working on these projects have prepared you for the engineering world?
These projects give you a lot of real-world experience. You start off the projects with design. You'll spend a lot of time at the computer designing components, looking at how things interact. But then you also go into the machine shop, and everything that we have done is made by the students. It's made all in-house. We machine every part. We weld everything together. We test it. We do everything that employers are looking for as far as manufacturing, testing, troubleshooting. We do all of that ourselves.
So you said that this snowmobile was for competition. When was this competition?
Our competition is in March, the second week of March. It's in Houghton, Michigan. We drive to Houghton every year for this competition, and this year we placed 3rd place overall. We got the most sportsmanlike award, we got the best value award, and we got several other awards that just show the progress of our snowmobile.
So this snowmobile is very interesting. Why don't you show me a little bit about the snowmobile and what the parts are?
Okay. This is a snowmobile that we used in competition about 3 years ago. It's a semi-direct injection snowmobile. Currently our engines, we use our direct injection. That's kind of our next step in this project. This snowmobile, I don't know, that's really all I got for this one.
I mean, show us a little bit about the snowmobile. Where is everything?
These are all carbon fiber panels that were made in-house by some of our team members. The engine is a 600cc Rotax engine with semi-direct injection. the clutches, but you can see it in there. There's semi-direct injection engine. We do a lot of engine work, engine tuning, a lot of dyno work. It's really, I don't know what it is. You want to move to one of these other?
We're going to show you some of the other projects since there were 3 projects, if you just give us a second. We can do this one first. Oh, they have a judge. Can we go to the other one? Oh, okay. So they can see the project down there. Why don't you?
Both of them or just one of them? Either one.
So just tell me a little bit more about this specific project.
This project is a senior design project that was done by 4 of our seniors. It's synchronous charge trapping. Basically, there's a valve in the exhaust system that closes or changes the port height to help eliminate some of the fresh fuel and air charge that leaves the cylinder. This is a totally new concept. There's been similar products where they have a reciprocating valve, but this one was designed with a rotary valve that should be a lot more durable and it's also variable, so we can change the timing of the valve system. I said it was a rotating valve. It's a rotating valve, unlike the reciprocating valve that Lotus and Boysen have designed. The engine to the far right is a 800cc engine with a custom cylinder head that was made by students here at the University of Idaho. It's our goal with that engine is to create an engine that runs at a lower speed but makes the same power, because currently at our competition we have a horsepower limit of 130 horsepower. That engine stock makes over that. So if we can run it at a lower speed, we'll produce less noise and we'll have better emissions and fuel economy.
So have you put this engine in a snowmobile yet?
Currently, no. The one on the left, the synchronous charge trapping engine, just was finished yesterday. It hasn't had any testing done. That's one of our goals before the end of the semester, is to get it on the dyno and hopefully to get it to idle and then to start tuning it. The one on the far right, the 800cc engine, also has not had any testing done on it. It was finished last year, but there were some issues between getting it ready for competition, and we just haven't had a chance to put it on the dyno. But both these engines should hopefully be running by the end of this summer.
So are you guys, once you get the engines running, are you planning to put them in another snowmobile for competition?
Most likely this next competition, the 800cc engine will be going in our snowmobile. The 600cc still has the synchronous charge trapping still has a lot of work that needs to be done as far as tuning and getting it to package and to fit into a snowmobile for production type use. The 800cc is a lot closer to meeting that goal.
So why don't we go look at the third project over here? So tell me what we have here behind us.
This is the third project. It's a muffler for the snowmobile. Some of our senior design team worked on cutting apart the stock muffler and seeing how it works, how it functions, looking at things such as back pressure and flow rates and things like that to design a muffler that is hopefully quieter. This muffler uses 2 hush power mufflers, which is a manufacturer out of Coeur d'Alene. It's a division of Flowmaster. They use 2 hush power mufflers in series with a catalytic converter to help eliminate some of those exhaust emissions and to reduce noise.
For those of us who aren't so engineering and technical, explain to us what the importance of a muffler is.
A muffler is basically just a way to reduce the overall noise level of the vehicle you're working with, whether it be a car, snowmobile, dirt bike, anything like that. This muffler is also unique in a snowmobile in that it has a catalytic converter, which is designed to reduce emissions. Basically, it's coated with precious metals that burn up unwanted hydrocarbons, which is unburnt fuel, nitrous oxides, which happen in very high temperatures, and then also CO, which is carbon monoxide, which is harmful to the environment.
Thank you, Austin. This is Valerie Berry for the 18th Annual Engineering Design Expo.